Yes. So this combinatorics is a field of mathematics in which we count things. So mostly we will be counting things. This is the actually structure. So these are the things that we are going to study. First we will see the basic principles. So we will see the very basic principles of counting, the product rule, sum rule, these kind of things. Okay, and also principle of inclusion exclusion. So the first thing we will do is we will see these kind of basic things. Then we will see one more principle, that is pigeonhole principle. Then we will talk about permutation combinations. Then we will talk about binomial theorem and binomial coefficients. So then we will go in more like these are the, in these cases we will solve easy questions. Now in this topic, this generalization, okay, here we will take more like complex questions. At the end we will talk about like generating functions and and then we will take more examples. So this is the structure of what we are going to study in this combinatorics chapter. Let's start. But the thing is, this combinatorics is actually comparatively easier, because you can see like the mathematical logic, the propositional logic, first order logic, these kind of things we study in computer science. These kind of things we have not studied in till our in our school or in general mathematics. So that's why mathematical logic was a different topic. Okay, that had some new terminology, some new notations, these kind of things were there. Okay, but this combinatorics, this counting, this we have been studying since our school. Even in our school we have seen these kind of things like permutation, combination, so these kind of things. So this is comparatively easier topic. Now let's start. So first, remember that this combinatorics is actually a typical mathematics. What is a typical mathematics? A typical mathematics in which you study some tools, in which you study some tools you study, and then using those tools you solve problems. Okay, so if I give you some problem, then what you will do? If I give you some problem P1, then what you will do? You know that you know many concepts, and then you will just go through this problem, and then you will decide which concept or which formula or which tool to apply to solve this problem. So this is what we are going to do in combinatorics also. In combinatorics also, we have some set of tools, some set of formulas, some set of laws, some set of theorems. So we will study all those theorems and all those things. Then when we encounter a question, then we have to like decide with our problem solving capacity. We will decide, okay, which tool to apply, which formula to apply, which theorem to apply. Okay, so the first the first rule that we are going to see is the product rule. This is a very basic rule. Let's see what is this product rule. So this product rule says that let me take an example. The example is that, let's assume that you want to make two-digit number. Let's assume that you want to make two-digit number. So like for example 0001, okay, like 99. So all these are two. What happened? Automatically zoomed. Yes, so what I'm saying, so let's assume that you want to wait, some problem is there, just give me 2 minutes, wait. Hello, recording we have already started, Sanjeev, we have already started recording. Okay, so let's see. So what is this this product rule? So let's assume that you want to make two digit two digit number. For example, this 00 is a two-digit number, for example 99 or 91 or 19, these kind of numbers. So if you want to make a two-digit number, then how many two-digit number you can make? So that is our question. How many numbers are there? For example, 0099. So if you count like 1 2 3 4, then how many numbers are there? So to solve this, we can see one thing, that if I want to make two digits, then what I can do, I can make this first digit in 10 ways. Why? Because I can put anything from 0 to 9 here. I can put anything from 0 to 9 here. So I can make this first digit in 10 ways. I can make this first digit in 10 ways. So basically, actually our task is to make two digits. But now what we are doing, we are we are dividing this task in two tasks. The first task is, let's make first digit. The second task is, let's make second digit. So the first task is, how many ways are there to make this first digit? So you know that there are 10 ways. Okay, you can put anything from 0 to 9 here. So this will complete our first task, and that task is to make first digit. Now our second task, so the first task was T1 and the second task was T2, and our main task was T. So this was our main task, that we want to make two digit number. So we have completed task T1. So basically, when I say we have completed task T1, that means that we have put one of these digits here. So let's assume that I put 9. Let's assume that I put 9. So you can see that task T1 can be done in 10 ways. Task T1 can be done in 10 ways. How many ways are there to do the task T2? Remember that task T2 is to make this a second digit. So again, to make this second digit, we can put anything from 0 to 9 here. We can put anything from 0 to 9 here. So you can see that a task T2 can be done in 10 ways. Basically, we can make this second digit in 10 ways. So we had a task T. We divided that task in T1 with T1 and T2. Now, when do we say that we have completed this task T? When do we say that we have completed this task T? So I can say that I have completed the task T when I have completed task T1 and I have completed task T2. So basically, I need to complete both these tasks. Task T1 also I need to complete. So I need to make first digit. Also, our task T2 also I need to complete. So I need to make second digit. So once I complete both T1 and T2, then automatically my main task was to create a two-digit number. So that will get completed automatically. Okay, so you can see that this task T will be done if I do T1 and T2. So this and so basically we need to do this task and this task. So the product rule actually says that if you have such scenario where your main task can be divided in two or more tasks, and those tasks you have to complete all those tasks. So basically there is an end. Okay, you have to complete T1 and you have to complete T2. If this is the scenario, then if there are 10 ways to solve, you already know that there are 10 ways to complete this task T1, and we know that there are 10 ways to complete this task T2. So there are 10 into 10 ways to complete this task T. So this is product rule. The product rule is saying that if there are n1 ways to complete this task T2, n2 ways to complete this task T1, and n2 ways to complete this task T2, then there are n1 multiplied by n2 ways to complete this task T. So this is our product rule. Okay, so you can see this product rule definition here. Suppose a procedure, okay, procedure or a task can be broken down into sequence of two tasks. And the thing is, let me just take one more slide. So the thing is, let's assume that you have this task and you have divided this task into two tasks. And the thing is that once you complete this task, okay, let's assume that there are n1 ways to complete this task, But the thing is, since there are n1 ways to complete this task, let's assume that you complete this task in some way. For example, you complete this task t1 by putting 9 here, right? Now once you put 9 here, then you can put any 10 digits here. So you can see that for every way we can complete this task t1, there are still n2 ways to complete this task t2, right? For example, if you want to put like 0 here, okay, instead of 9, then also we can put then also this task t2 can be done in 10 ways, right? So you see, for every way so for every way to complete this task, for every way of t1 we have n2 ways of t2, right? For every way of t1 we have n2 ways of t2. For example, in our example, if I complete this task by putting 9 here, then for this way of completing task t1 we can still complete this task in 10 ways. So that is what I want to say. And finally you need to complete both the task t1 and t2. So i- the number of ways to complete this task t1 will be n1 into n2. So this is the product rule. Okay, we will take more examples, don't worry if you did not understand. So what I want to say is that suppose a procedure can be broken down into two tasks. If there are n1 ways to do the first task, okay, and for each of these ways of doing the first task there are n2 ways to do the second task, then in total there are n1 into n2 ways to do our procedure. Let's take one more example. Let's take this example. So this example is in this city, license plates consist of two letters followed by three digits. So basically if I have a license plate, let's assume this is the license plate, then that license plate, the first two things are letters, okay, English letters, let's assume a b c d and so on, and followed by three digits. So three digits. How many possible license plates are there? So you see, our task is to create license plates. Our task is to create license plate, and for to creating license plate, we can break down our, so we can break down our task into five tasks. The first task is to create the first letter. The second task is to create the second letter. The third task is to create this third digit. So now this t4, this fourth task is to create the fourth digit, and this final task, this t5 task, is to create the fifth digit. Okay, so you see, when we complete all these tasks, we complete this task and this task and this task and this task and this task, then we can say that once we complete all these tasks, our our main task, that was creating license plate, that will automatically complete. So you can see here we can use a product rule, because you can see here there is and, okay, if this task is t1, this task is t2, t3, t4, t5, then there is and between them, t1 and t2 and t3 and t4 and t5. So here we can use product rule. So how many ways are there to complete this t1 task? You know that there are 26 ways. Why? Because the first task is, the first task t1 is to put a letter here. And how many letters are there? You know that there are 26 letters. Now once we put some letter here, let's assume that I put a here. Now again I can put 26, any of the 26 letters here, right? I can put anything from a to z here. So you can see that we again have 26 ways to complete this task. Okay, once I complete these two tasks, once I put something here, and let's assume I put something here. Now to complete this task we again have 10 ways, because you can see now this third task is to put a digit here. This t3 is to put a digit here, and to put digit here we have 10 ways. Okay, so similarly once we put some digit here, let's assume I put 0 here. After putting 0 here, you can see that now still I can put any of the digits from 0 to 10, 0 to 9 here. So I can complete this task in 10 ways. Similarly I can complete this task in 10 ways, and the final of our main task will be completed in this 26 multiplied by 26 multiplied by 10 multiplied by 10 multiplied by 10. these many ways. So this will be the answer. So you can see we have applied this. What we have applied is our product rule. Okay, let's take this. So this is the solution. Okay, this is the solution. Now let's take one example and you try to solve it. So actually this is how we will proceed in this combinatorics course. We will this is how we will proceed. So we will learn a concept. We will learn a concept. Okay, then I will solve one or two questions on that concept. Then I will ask you to solve one or two questions on that concept. Okay, so this way we will complete, okay, all the concepts one by one. There are around 10 concepts we have, and by that we will complete our combinatorics course. Okay, so this is the question, try to solve. Also you have written 132, so just write the solution in terms of multiplication, like 26 multiplied by 26 multiplied by 10 multiplied by 10 multiplied by 10. So this way I will get to know, okay, how you have gotten this answer. 12 multiplied by 11, yes, right. So you let's solve this. So basically this is saying that a new company with two employees. So there are two employees, there is E1 employee and let's assume that E2 employee. Sorry, okay, name are also given, but okay, let's rents a floor of a building with 12 office. So there is a building, so you can see like this is the building. Let's assume this is the building and there are 12 office here. So there are 12 office here. How many ways are there to assign different offices to these two employees? Now, so what will be our answer? So you see we have what is our task. What is our first we need to decide what is our task. So our task is that we have employee E1, we have employee E2, and our task is to assign office to both E1 and E2. Remember that our task is to assign office to both E1 and E2. So you can see there is an and here. So I can divide my task into two tasks. The first task is to assign office to E1, then the second task is to assign office to E2. So these are the two tasks. I have divided my main task into these two tasks. Now, how many ways are there to complete this first task? So just this first task. The first task is to assign office to E1. So how many ways are there? You know that, okay, you can assign any of these 12 office to him. So there are 12 ways. So there are 12 ways. And you can assign any one of the office to him. Let's assume I assign him department D1. Let's assume there are department D1 to D12. Let's assume. So let's assume that I assign him D1, but we can do this task in 12 ways. Now once I have assigned him this D1, now how many ways are there to complete this task? You can see now I cannot assign this D1 to this E2. Okay, because D1 I have already assigned E1. So once I complete this task, for each way of completing this task, I have 11 ways to complete this task. So I have 11 ways to complete this task, hence the final answer will be 12 into 11. So this is a simple principle. This is a very basic principle, this product rule. Now we will see what is a sum rule. Now let's see what is a sum rule. So this is the answer. You can refer to this answer. I will share slides so you can refer to this answer. Now let's see our next. Okay, let's take this next question. Solve it. How many different bit strings are of length 7 are there? What do we mean by bit string? We already know that, okay, what is a bit? So 0 or 1. So basically a bit either can be 0 or it can either be 1. Now it is saying that how many bit strings are there of length 7? For example, 0 1 0 1 0 0 0. You can see this is a bit string of length 7, of length 7. Now we need to find how many bit strings are there, okay, with length 7. Kindly solve it. Again, you do not need to multiply, you do not need to give the final answer, you can just give answer in a way multiplication. So yes, 2 power 7, 2 power 7, right? So basically again the thing is we have a task, and our task is to our okay, our task is to create a 7 length string. 1 2 3 4 5 6 7. We our task is to create a 7 length string. So I can divide this task into 7 tasks. Okay, I will create the first bit, then I will create the second bit, then I will create the third bit, and so on, then I will create the last bit. How many ways are there to create this bit? We know that there are two ways to create this bit. Either way, I can put 0, or I can put 1. Now once I put something here, once I put something over, for example, if I put 0 here, then how many ways are there to complete this task? Okay, so then again there are two ways, because even if you put 0 here, you can again put either 0 or 1 here. So again there are two ways. Similarly, you can see that there are two ways here, two ways here, and so on. So now finally you multiply. Why are we multiplying? Because our task is to create a 7 length string, and we have divided it into 7 tasks. But to complete our main task, we need to complete all these tasks. We need to complete this task and this task and this task, and so on. So there is a end. So there is a end. This word actually indicates that we need to use product rule. Okay, so now finally we multiply all of them, and we will get 2 power 7. So this is our answer. Very good. Now let's discuss some rule. Okay, so this is the answer. Okay, this is the solution. You can refer to this solution after this lecture is over. Now the next rule we have is the sum rule. So what, let's take one example. For example, in a university, let's assume there is a university, and in this university we have two departments. Okay, one department is, let's assume computer science department, and the other department is mechanical department. Let's assume in computer science department we have 10 faculties, 10 teachers, 10 t mean 10 teachers. And in mechanical department, let's assume there are 15 teachers. And let's assume that these 10 teachers are different from these 15 teachers. Basically uh, these are disjoint, like there is no teacher who is in both these computer science and mechanical. So let's assume there are 10 teachers here and 15 teachers here. So basically there you can see that there are total 25 teachers, right? And what this university wants to do, this university wants to send one teacher on a conference. Okay, maybe there is some conference here, and this university wants to send one teacher to this conference. Now this university either can send a teacher from computer science department, or it can send a teacher from mechanical department. So basically you can see what is the main task here. The main task is to send one teacher. Now that task I can divide into two tasks. The first task T1, the second task T2. The first task T1 is that, okay, send one teacher from computer science department. Okay, basically our main task is to send send one teacher. Now I have divided it into two tasks. The first task is to send one teacher from computer science department, and this task T2 is to send one teacher from mechanical department. Now our main task will you tell me, our main task, when it will get complete, when will we complete our main task? When we can, either we can complete this task T1, or we can complete this task T2. We do not need to complete both tasks. Why? Because okay, we can either pick one teacher from here, and then we can send, then our task will be completed. Our main task will automatically get completed even if we do not complete the task T2, right? For example, if I select a computer science teacher, and if I send them to this conference, basically I have only completed task T1, but still my main task automatically got completed. So you can see that my main task can be divided into two tasks. And if I complete task T1, or if I complete task T2, automatically my main task will get completed. So you can see this word or is coming. basically this word or is coming between these subtasks. So this or is telling us that if this task T1 can be done in n1 ways, and let's assume this task T2 can be done in n2 ways, and let's assume that these are disjoint. So basically uh, every one of these ways is disjoint from every one of these ways. Okay, let's assume that, then our main task can be completed in n1 plus n2 ways. So because this or is coming. Okay, so this is our sum rule. This is a very simple rule. Let's see this. If a task can be done either in one of the n ways or in one of the n2 ways, where these n1 ways and n2 ways basically they are different, like they are disjoint. Okay, then the our main task can be completed in n1 plus n2 ways. Let's take, so we have already taken one example to illustrate our point. Now let's take this example. So maybe you can directly try to solve it, because this is such a easy rule. So try to solve it. This is our question. Again, you do not need to give the final answer, just give like the breakdown, like maybe 2 plus 3 plus 4 plus 5, that kind of breakdown. Right. So Sanjeev, have you tried, or is there some problem? Should be right. Okay. So basically, the same. This is the same example. So he is saying that suppose either a member of mathematics faculty or a student, okay, is chosen as a representative. So basically we have some mathematics faculty, and then we have some students, and one of them is chosen as a representative for some conference. How many different choices do we have for the representative if there are 37 members here and there are 83 students here? And it is saying that no one is in for basically they are disjoint from them. Okay, so they are different. So again, we can use the sum rule. Why we are using the sum rule? Because our main task can be divided into two tasks. Okay, and we can complete, if we complete this task, then automatically our task will get completed. So basically our main task will complete if we complete this task or we complete this task. So because of this or, we are actually, so if our this task can be, you know that this task can be completed in 37 ways. Why? Because this task is to send a faculty to the conference. Okay, so how many ways are there to send a faculty to conference? There are 37 ways. Similarly, this task is to send a student to conference, so there are 83 ways. So since we can either complete this task or we can complete this task, hence our total number of ways to complete our main task will be 37 plus 83. So this is such a simple rule. These, remember, these are the very basic rules, but we use them again and again and again. In complex problems we will use them. Okay, so that's why they are useful. Okay, this is the solution. So I have completely written this solution. You can read it out while you revise after this lecture. Let's take one more question. Try to solve this question. Right. So a student, the again the same very easy problem. A student can choose either choose a computer project from one of the three lists. Okay, let me tell you actually in ISC they have, for example, in ISC computer science department is there, CSA department is there. In CSE department, they have three pools. They have three pools. There is a pool A, there is a pool B, there is a pool C. So in pool A, we have theoretical courses. In pool A, we have theoretical courses like algorithm, discrete mathematics, cryptography, these kind of courses, graph theory, theoretical courses. In pool B, we have system courses like operating system, computer organization, compiler design, these kind of courses. In pool C, we have intelligent system courses like machine learning, data science, game theory, these kind of courses. So in ISC, we have these kind of pools: pool A, pool B, pool C. Okay, so similar question is here. So basically, we have three pool, we have three list, and in this we have 23 courses. In this we have 15 courses. In this we have 19 courses, and he is saying that okay, no project is in one, so basically all these are disjoint. Okay, if there is a course here, then that course is not present here and here, so basically they are disjoint. How many possible, we want to choose one course. Let's assume you get admitted in ISC, and then you want to choose one course. Then you can either choose course from here, or you can choose course from here, or you can choose course from here. So you can see there is a or. So this or, now we get to know, yes, we can apply some rule. So what how many ways are there to complete this task? There are 23 ways. You can choose any of the 23 courses, or you can choose any of the 15 courses, or you can choose any of these 19 courses. So finally we can choose one course in these many ways. So this is a very simple principle. Now let's move on to our next. So this is the solution. Again, there is one more question. Okay, just solve this also, just for the sake of practice. We have already like there is no, so just solve it. So yes, solve this question. Solve it in your copy in your notebook. Keep a notebook and pen with you. Solve this question on your notebook, and you can give me a final answer maybe, because maybe the breakdown, giving this breakdown maybe not easy thing, writing. So you can maybe final answer you can give, or if you want me to discuss it, then I can discuss it. You can let me know whether you want me to discuss it or not. Should I discuss it, or are you trying? Similarly for 7 and 8 and add. Right, right, Sanjeev. Gayatri, are you trying, or shall I discuss? Okay, let's see. So what this question is saying, he's saying that each user on a computer system has a password which is 6 to 8 characters long, where each character is uppercase letter or a digit. Each password must contain at least one digit. How many possible ways passwords are there? So you see, this is actually complicated question. This will use both product rule and sum rule. So so let's just break down our task. Our task is to create a password. Okay, let's break down our task. So our task is to create a password. Now he's saying that password either can be 6 to 8 letters. So basically, let's write it like this: T6, T7, T8. So this T6 means password of length 6. This T7 means password of length 7. This T8 means password of length 8. You know one thing, that we want to create a password. We want to create a password. Then we can either complete this task, or we can complete this task. Why? Because we can either create a 6 character password, or we can create a 7 character password, or we can create a 8 character password. So you can see there is or here. Okay, so now we will find how many number of ways are there here. For example, let's assume that number of ways to solve this T6 is n1. This number of ways to solve this T7 is n2, and number of ways to solve this T8 is n3. Let's assume this. So you know one thing, that final answer will be n1 plus n2 plus n3. Why? Because you can see, either you can do this task, or you can do this task, or you can do this task. Also one more thing, that you can see, no password of 6 length is a password of 7 length. So basically all these passwords are distinct from these passwords. So you can see all these T6, T7, T8, they are disjoint tasks, right? Because if there is a password here, then that password will not be here or here, because this is a 6 length password, these are 7 length password, and these are 8 length password. So our final answer will be n1 plus n2 plus n3. Now we need to find what is n1. So what is n1? N1 is nothing but a T6. Okay, you know that n1 is number of ways to complete this task at T6. Now what is this task T6? Task T6 is to create a six length password. 1 2 3 4 5 6. So this task T6 is to create a 6 length password. And now we want to construct a 6 length password. Now he is saying that we can either use a uppercase letter. So basically there are 26 letters, or we can use a digit. So there are 10 digits. So total these 36 things we can use. Okay, so but he's also saying one thing, that each password must contain at least one digit. Okay, so what we can do, we can do this kind of thing, like we can find total, we can without considering this condition, we can find how many number of ways are there to create a sixth length password. So then what we will do, we will subtract those passwords which do not have any digit. Okay, so if we subtract those passwords which do not have any digit, then automatically we will be we will be having only those passwords which have at least one digit. So this is our target. So what we can do, basically, we can find all the cases. So how many cases are there? You know that there are 36 ways are there to complete this task. Okay, 36 ways to complete this: 30, 36, 36, 36, 36. So finally 36 power 6, these many total sixth length password I can make. 36 power 6. right? This we can do by product rule, right? We have already discussed this kind of question. So there are total these many passwords, these are the total number of passwords, but these password actually contain those password also which do not have any digit, right? So now we need to subtract those cases when there is no digit in this password, when there is no digit in this password. Okay, so how many passwords are there which do not contain any digit? So you know that if password does not contain any digit, then I can put 26 characters here. For example, any of the 26 characters I can put here. So this task can be completed in 26 ways. This task can be completed in again 26 ways. Why? Because I cannot put a digit here, because this is the number of passwords which do not contain any digit. So how many ways are there? 26 power 5. So these are the passwords which do not contain any digit, and these are the total six length password. If we subtract from total, if we subtract these passwords, then these are the passwords which have at least one digit. Okay, so this is what we wanted. So this is our n1. So this is our n1. So n1 is nothing but 36 power 6 minus 26 power, sorry, this is 6 minus 26 power 6. Okay, now you can find n2 also, you can find n3 also. So just you can try it, and the n2 will be basically 7 length password we are looking for. So n2 will be just, okay, just make it 7, just make it 7. So this will be n2. How n3 will be, just make it 8, just make it 8, because n3 is creating a 8 length password. So now we know the value of n1, we know the value of n2, we know the value of n3. Now we can just add them, and that will be our final answer. Okay. So this actually, you see, we were looking at simple principles, we were taking simple examples, but using those tools we can solve these kind of complex questions also. So in this question, many concepts we have used first, you can see, first we used the sum rule. Then we used this product rule. So this 36 power 6, this comes by product rule. Then we also used one more strategy, and that strategy is, from total we are subtracting undesirable cases. So this is one strategy. So basically this is one strategy. What is the strategy? That sometimes to find desire, to find desirable, desired cases, what we can do, we can find total cases, then we can subtract undesired cases. Okay, so this strategy, this technique, okay, we have used in this question. So you see, actually we are building our toolbox, we are building our tools, we are building our theorems and these kind of things, so that when we encounter a problem, then we can use our toolbox and then we can solve that problem. Okay, and some problem might require us to use many tools. Okay, so all these theorems, these product rules, some rule, okay, these all are our tools. Okay, and these tools we use to solve problems. So here is the solution. You can go through this solution after this lecture is over. We have already discussed this thing. Now finally, finally we have this subtraction rule. Actually, this subtraction we have rule we have already seen. So this subtraction rule says that desired cases is equal to total cases minus undesired cases. This is subtraction rule. Okay, so we have already seen this subtraction rule in our previous example. So let me just read it out for you. So it is saying that if a task can be done in either n1 ways or n2 ways, then the number of ways to do task is n1 plus n2 minus the number of ways to that are common. Okay, so let me just take this example. For example, let's take this example. uh, you have a university, and in that university, let's assume there is a CSE department. Again, the same example, there is a math department. In this CSE department, let's assume there are 20 teachers. In math department, we have assume 40 teachers. Now we have already seen how may and again the task is to send one professor to conference. We have seen this question already in our sum rule, where but there was the condition that these 20 teachers are different from these 40 teachers. But what will happen, let's assume five teachers are such that, okay, five teachers are such that they are teacher in CSA department, also in math department. So you can see there are five teachers which are here also, and these five teachers are here also. Now now can you tell me how many ways are there to send one professor to the conference? Try it try it how many ways are there to send one professor to this conference? How many ways will be there? Right, right. So basically what we are doing actually, again the same thing, that we have this task. The task is to send one professor to conference. We have divided this task in two tasks. The one is T1 and the other is T2. The task T1 is to send one professor from CSE department, and the task T2 is to send one professor from math department. So we know that our whole task will be done if we can either complete this task T1 or we can complete this task T2. So there is a or here. Now, number of ways to complete this task T1 is n1, and that is equal to 20. We know that the number of ways to complete this task is 20, and the number of ways to complete this task is 40, right? So now, uh, if they were like both, you see, number these ways, if they were different from these ways, then we would have just added them 20 plus 40. But you see, these ways are not exactly different from these 40 ways. Why? Because five ways are there which are here also and here also, because of those five teachers. So five ways are here which are here also, and they are here also. Okay, so when we do 20 plus 40, what we are basically doing, when we do 20 plus 40, then we are adding those five cases here also and here also. So basically we have considered those five cases here, we have considered those five cases here. But so basically those five cases we have considered two times, so we should subtract those five cases one time. Okay, because if we have counted them twice, then if we subtract them one time, okay, then we will find then we will get our correct answer. So this is our subtraction rule. Subtraction rule says that if a task T1 divided into task T1, sorry, task T divided into T1 and T2, let's assume there are n1 ways to task for task T1 and two ways to complete this task T2, and let's assume that they are not mutually distinct. For example, let's assume that n3 ways are here also and they are here also. Then our final answer will be n1 plus n2 minus n3. Why we are subtracting n3? Because we have counted those n3 here also and here also, and that is what so basically these n3 cases we have counted twice. So that's why we are subtracting them once. Okay, so this is our subtraction principle, a very easy principle. Now let's solve this question. So solve this question. How many bit strings of length 8? So we want to construct bit strings of length 8, but he's saying either start with 1 or end with 0 0. Either start with 1 or end with 0 0. Solve it. Okay. 2 power 7 plus 2 power 6 minus 2 power 5. Right. So Sanjeev Gayatri, correct answer. So just let me discuss it. So basically our task is to create 8-bit string. That is our task, 8-bit string. So to create 8-bit string, we can he's saying that either you can start with 1 or you can end with 0. So basically this t1, and let's call it t00. So this means that okay, you start with 1, and this means that end with 00. Now how many ways are there to complete this task? So this task is to basically this task is creating 8-bit string such that the first bit is 1. So you know that the first bit is already 1, so you cannot do anything about the first bit. But for the remaining 7 bit, you can create 2 power 7 ways, right? Because you can put any of the digits, any of the digits in these places, right? So 2 power 7, we have already seen this. Now how many ways are there to complete this task? This task is to number of strings which end with 00. So basically end with 00. So for the last two places we do not have any choice, but for the first 6 places we have 2 power 6 ways. So you can see 2 power 6 ways are there, 2 power 6 strings are there which end in 00. Now there is one thing. What is that thing? That we could have actually just added them, we could have just added them. But what will happen, there are some strings which we have counted here also and here also. For example, those strings which start with 1 and end with 00. What about such kind of strings? These kind of strings we have counted here also, we have counted here also. So these kind of strings we have counted twice, 2 times. So we need to subtract them one time. So now how many strings are there which start with 1 and with 00? You know that okay, 2 power 5, because there are these 5 places you can fill in 2 power 5 ways. So we will just subtract 2 power 5. Now this will be our final answer. Okay. So let's see our next so this is the solution. You can just refer to this solution, complete detailed solution this is. Now now we have this question. Solve it. Try to solve it. Solve it. 34, huh? Okay, yes, correct. 34 is correct. Yes. So just for the sake of, actually you already know, so do I need to discuss? Because just tell me, do I need to discuss? Because if not, then we can just proceed, so that we can quickly cover more concepts. Okay, so you can just let me know, because if you can solve these questions, then there is no need to discuss, I think. Okay, but so yes, let's proceed. So this is the solution. Okay, even since I am not discussing, but I have written this solution here. Okay, so this detailed solution is here. Okay, you can, maybe you can go through, or maybe the students, those students who have not who are not present right now, they can go through this detailed solution. So this is the solution. Okay, for every question I have provided detailed solution. So okay, let's move on. Now we come across the division rule. So let me just take one example, and then let me tell you what is the division rule. So the division rule is actually simple. What we are saying, that let's assume that we have some like set. Let's assume that we have some set. Let's assume that this set is a set of all, for example, there is some party. Let's assume there is some party. In that party, let's assume 100 family, sorry, let's not write like that. Let's assume in that party 500 people came. Okay, so in this party, okay, how many people came? So there are 500 people came. But actually, these all these people, they are from families. So basically, each family has 5 person. Okay, so each family, there is a city. In that city, each family has 5 people. Okay, so maybe mother, father, and then three siblings. Okay, so each family has five people, and in this city, there is a party, and in that party 500 people have come. Okay, so now your question is, now my question is, how many families are there in this city? How many families are there in this city? Can you answer it? How many families are there in this city? Right, 100. So this is actually, this can be done by division rule. How we can do this by division rule? So what we can do, we can write a set like this. Okay, and we already know that let's assume these are these 5 people, the first person, second, third, fourth, fifth. Let's assume these 5 people, these first 5 people, let's assume they belong to the same family. Okay, so these 5 people are from family f1. Let's assume the family f1. So I can write like this. So they are from family f1. Now the next 5 people are from family f2. Okay, so now this way I can go on, right? I can go on. So basically, for every 5 people, I am having one symbol in this set, right? And for every 5 people, I am having one symbol in this set. So you know that, so our question is simple: how many symbols are there in this set? Because these number of these symbols are nothing but the number of families. So since, okay, for every 5 symbol we are putting one symbol here, for every 5 people we are putting one symbol here. So our final, the cardinality of, or you can say the cardinality of this set will be nothing but a cardinality of this divided by 500 divided by 5. Remember, this 500 is the cardinality of this set, and this 5 is you can say degree. 5, you can say degree, because every element here is actually connected to 5 people here. Every element, for example, this element is also connected to 5 people. So you can think of this as a degree. So finally, we will have the cardinality of this set will be 100. This is our division principle. Okay, so let me just give one more illustration. So basically, what I want to say, I am saying this. For example, if you have a set S. Let's assume this is the set S, and this set has cardinality n. Let's assume this set has cardinality n. Now, let's assume we have another set P, and we have a function such that, that what that function does is d elements. For example, these are the d elements, and we have a function. Basically we have a function f. So this is a function, right? This is a function, and what it is doing, it is taking these d elements, and it is assigning these d elements to some element. For example, maybe some element a1. Okay, similarly again, these d elements are assigned to some element a2, and so on. So basically you can see, you are picking d elements, and then you are assigning them to some element in this set. Okay, this set has cardinality n, and every d sorry the set of these d people, you are assigning them to some element in this set. So how many, what will be the cardinality of this set is our question. What will be the cardinality of this set is our question. So that will be nothing but n divided by d. I hope this is clear. Just simply because there are n people here, and we are taking d people. For every d people, we are having one person. For every d people, we are having one person. For every d people, we are having one person. So finally, how many symbols are in this set? So that will be n divided by d. So this is a simple this division principle. Now we can try to solve questions on this division principle. Before that, let me just go through this. There are n by d ways to do a task if it can be done using a procedure that can be carried out in n ways, and for every weight w, exactly d of n ways correspond to weight w. Okay, so this is a you can say this is a tedious definition, but let's understand this definition. It is saying that, let's assume you want to complete this is the set of task. Okay, this is the, you can say the cardinality of this set is actually number of ways you want to do a task. For example, you have task t, and this task t can be completed in for example in let's assume this can be completed in these many ways. Okay, so this w1 is one of the ways to complete task t. Okay, now he is saying that there are n by d ways to do a task if it can be done using a procedure that can be carried out in n ways. So this n is the cardinality of this. Okay, and for every way w, so for every way w, exactly d of these n ways corresponding to this w. So actually this is the okay, this is the meaning of this statement. Okay, so this is a very tedious statement. Actually, you do not need to worry about it, if even if you do not understand. Just too much language is there. Okay, but we have we have told you what is the concept behind this division principle. And the concept is very simple. You have a set here, and that has cardinality n, and you have a set here, and we want to know what is the cardinality of this set. But we have this additional information that for every d people here, we are having one person here. For every d person here, we are having one person here. So finally, what will be the cardinality of this set? This will be nothing but n by d. So this is the meaning of division principle. So we can restate. So basically now this is simple. Like if we have a finite set a, so this is set a. Okay, this if this is set a, so if we have a finite set a. Okay, what is happening? Yeah, and he's okay, wait, what is happening? So some problem with pen. Okay, now it is clear. So what it is saying, so basically if there is a set a is the union of n pairwise disjoint subsets. So you can see these d ways. Array, what is happening? X, I don't know what is happening. Some mistake with pen. Okay, so what we were saying, yes. So you can see this statement is saying, what is this statement saying? Let me just write it. So this statement, the second statement, this is saying that if we have a set a, and in this set, if we have disjoint subsets. For example, this subset is disjoint from this subset. Okay, and let's assume this subset has size d, this subset has size d. So basically they are disjoint. Okay, these two are disjoint. Okay, similarly let's assume this subset has size d, and this is also disjoint. If this is the case, then you can say that there are total n by d subsets. So you can say that there are total n by d subsets. So this is our division principle. Okay, so enough about it. Now just try to solve this question. Let's try to solve this question. How many different ways are there to seat four people around a circular table where two seatings are considered the same when each person has the same left neighbor and the same right neighbor? Let me just, you know, what it is saying, let me just clear it. For example, there is a circular table and let's assume there are four people sitting. For example, A is sitting here, B is sitting here, C is sitting here, D is sitting here. Okay, now let's assume that next day what happens. Next day A goes here, B goes here, C goes here, and D goes here. So we, what this question is saying, this question is saying that these two sittings are considered the same. So basically he is saying that these two sittings, okay, these, this and this are, he is considering same. Why? Because you can see that we can get this seating we can get by just rotating the table. So basically what we can do, just rotate this table to, to this clockwise direction. Just rotate this with for 45 degrees. So basically this A will come here, this A will come here, this B will go here, this C will go here, D will go here. So you see, if we just rotate this table, then we will get this seating. So that's what he's saying, that we do not consider them different. Okay, these two are same sittings. Okay, he's also basically this same thing that I have told you. I have told you that okay, you can just rotate this table and you can get this configuration. Okay, but this same thing can be also stated like this, that each person has same left neighbor, right neighbor. For example, consider this A. You can see he has same you can see his right neighbor is B and his left neighbor is D. Okay, so now A has come here. You can see still his right neighbor is B and his left neighbor is D. So okay, you can see this, right? So he has same left neighbor, same right neighbor. Okay, even here also. Okay, so these two sittings are considered same, they are not different. Now you need to answer how many sittings, different sittings are possible. Remember that these two sittings are not different. So just tell me how many different seatings are possible. Try it, then we will see. Okay. So you are trying, right? Once try yourself, so that if you get the answer, then that is a very, like, very nice. Even if you do not get the answer, then you can you can know where you were making a mistake. Okay, let's see, let Sanjeev also try, then we will discuss this question. Yeah, sure, no problem. Can you share your approach, Gayatri? Like how did you solve it? I want to know the approach, whether you used the division principle or whether you solved it by some other method. Because to solve same question, there may be many methods. Just want to know your approach. Answer may be right or wrong, that doesn't matter. Just just the approach. What was the approach that you tried? I put one person in one position. So for next position, I have three choices. Then two, then one. Okay, six ways. Okay. So let's see. Now you can know whether whether you were making a mistake or not. Let's see. So the thing is, first let's discuss Gayatri's approach. So what Gayatri is doing, so that we can see whether some mistake is there or not. So what Gayatri is doing is that Gayatri is putting some chair here, then putting some chair here, a chair here, and a chair here. Now what Gayatri is doing is that she can put one person here. Okay, and she can do this in four ways. Oh, and now to once she has completed this task, then she can complete this task in three ways. She can complete this task in two ways. This she can complete this task in one way, and then finally from product principle we will get 24. So yeah, actually to some extent this is correct, but there is some problem. What is the problem? Let's assume that you put A here, then you put B here, then you put C here, then you put D here. Let's assume this is the case. Now in another, so you know that this is one of the ways in these 24 ways, right? This is one of the ways in these 24 ways. Now another way in these 24 ways, another way in these 24 ways is that you put D here, you put A here, you put B here, you put C here. But we are saying that this arrangement and this arrangement, actually they are exactly same. Why? Because you can see that in this arrangement every person has the same left and right neighbor. Because so you can see in this arrangement and in this arrangement you can pick any element. Let me randomly pick any element. For example, let's pick B, or let's pick C. Let's pick C. So you can see this this C has right neighbor B, okay, and left neighbor D. Okay, right neighbor, so I can say that right neighbor B and left neighbor D. But now just let's come to here. So here what will happen, this C again, this C is having right neighbor as B. You can see he's again having right neighbor as B and left neighbor as D. So you can see for every element, for every person, the in these both these arrangements, the left neighbor and the right neighbor, they are same. And this is what this question is saying, that such arrangements are considered to be same. So basically these two arrangements you have considered in these 24 ways, but actually you should not have considered them as different. They are same, they are same. Okay, so that's why this 24 is not correct. This 25 would be correct if this condition was not given. If this condition was not given, then 24 would be correct. So now what should we do? Now what should we do? So I am telling you one thing, that you can, this condition, what condition, that everyone has same left neighbor, right neighbor. This condition you can also, you can see that this condition is same as, this condition is same as, if you rotate this table, then you can get this configuration. For example, if you rotate this table just like in clockwise direction just one time, then you will get this configuration. Now let's assume we rotate this table again in clockwise direction, then what will happen? A will go here, D will go here, B will go here, C will go here. Again, this configuration is same as this configuration is same as this configuration. If I again rotate this one time, let's assume if I rotate this one time again, then A will go here, B will go here, C will go here, and D will go here. So this configuration is same as these three configurations. Now if I rotate this table again, then I will get this configuration. Okay, so you can see that if I have in your these 24 ways, in your these 24 ways, you can see that you have counted them 4 times, you have counted them 4 times, but these 4 are actually should be counted only once. These 4 should be counted only once. So you can see for any configuration, for example this configuration, for example this configuration, okay, for example this configuration, for this configuration in these 24 ways we have counted 4 times. Okay, are you getting my point? So that is what I want to say. So basically what I'm saying this. So these are your 24 ways, these are Gayatri's 24 ways. I am saying that these are the correct ways, this set is the correct ways. Okay, now I'm saying that if I have a correct way here, if I have a correct way here, for example A is here, B is here, C is here, D is here, if I have let's assume this configuration is this, so this is the way. So for this way Gayatri has counted them 4 times, Gayatri had counted them 4 times. So 4 times she has counted. Similarly, if I pick any different configuration, for example if I pick different configuration, for example if I pick B here, A here, D here, C here, now you can see these two are different, these two are different, right? So why these are different? You can see you can never get this configuration by just rotating the table. You will have to if you just rotate this table, you can never get this configuration. Okay, so that's why this configuration is different. So now yes, so for this configuration also Gayatri has counted 4 times. Gayatri has counted 4 times. Now you might be looking at, okay, what I am trying to do. So basically you have this set which has cardinality 24, so there are 24 ways, but you need you need the this is the answer that we want the cardinality of this set. And also there is one thing that for every these 4 ways you are counting them once. So for example these 4 ways we want to count them once, for these 4 ways we want to count them once. Similarly more they might be 4 ways we want to count them once. So finally what by division principle our answer will be 24 divided by 4, that will be 6. I hope this is clear. Is this answer clear? This division by this division principle I have solved it. Okay, so yes, this is this is not a intuitive question, but you can try to solve it again after the today after today's lecture. Try to solve it again, and also try to try to see why this condition, what was the condition that every person has same left or right neighbor? Why this condition actually is same as rotating the table? Okay, I have not given you proof of this claim, because basically I claimed that if we just rotate the table, then neighbors will not change. Okay, so you can after today's lecture you can put some effort on this question. Also you can understand how this division principle I have used. Okay, so all these things you can again revisit. Okay, so this question is worth revisiting. Okay, now let's go to the next part. So yeah, you can see that I have given the solution here, I have given the solution here. Okay, you can also go through this solution if you did not understand. If there is any part that you did not understand, then you can go through this solution. Now we will see what is a pigeonhole principle. Now this pigeonhole principle is a very intuitive principle. So this is a very intuitive principle. Basically this pigeonhole principle, what it is saying, let's assume that there are 3 rooms. Let's assume that there are 3 rooms, and let's assume that there is a there are 4 students. There are 4 students. So basically there are 3 rooms and there are 4 students. Now this pigeonhole principle is saying, since there are 4 students and there are only 3 rooms, hence at least one room must contain 2 students, right? Because there are 4 students, okay, then at least one room must contain more than one student. For example, maybe 2 students come here, one student go here, one student go here. You can see at least one room will contain more than one student, okay. Or maybe this kind of situation that 3 students come here, one student come here. Still our claim, what was our claim? That at least one room will contain more than one student. That is true. So this is a very easy principle actually. When we study this principle, this statement is very easy, anyone can understand it. But the problems that are asked in this, that the problems that can be solved by this principle, they are very very sophisticated problems, very good problems we can solve using such a simple principle. So basically what this principle is saying, that let's assume that there are some pigeonholes. These are the pigeonholes. Okay, let's assume these there are n pigeonholes. Okay, so these are the n pigeonholes. Okay, hole 1, hole 2, and so on. Now let's assume some n plus 1 pigeons, they came and now they want to rest in these pigeonholes. Then it is a very very intuitive thing that since there are n plus 1 pigeons, so at least one hole must contain more than one pigeon, right? So at least one hole must contain 2 or more pigeons. So this is the simple pigeonhole principle. This is the statement. Let k be a positive integer and let k plus 1 or more objects. So basically it is not a mandatory thing that you have n plus 1. You can have any number greater than n plus 1. For example, if n plus 2 pigeons come, then also it is true, because there are n pigeons and there are n plus 2, sorry, there are n pigeonholes and there are n plus 2 pigeons. So at least two pigeon must go to same hole. Okay, but what will happen? Can you tell me? Can I say if there are n pigeons and n pigeonholes, can I say that at least 2 pigeon will go to same pigeonhole? No. Why? Because there are n pigeons, so every pigeon can go to different pigeonhole. Hence, I cannot say that at least 2 pigeon will go to same pigeonhole. But if there are n pigeonhole and if my number of pigeons are more than n, okay, either n plus 1 or n plus 2 or something, then at least 2 pigeon must go to same pigeonhole. So now basically in our this definition we have used the number boxes instead of pigeonhole, and number we have used this word object instead of pigeons. Okay, so but you can understand how this pigeonhole word comes. Okay, so this is a very simple, very intuitive principle, pigeonhole. So anyone actually can understand the statement of pigeonhole principle. This is such a simple statement, but you know, you will be surprised to see how many complex problems this simple pigeonhole principle can solve. Okay, so like in graph theory, when we will study graph theory, at that time I will solve 2 or 3 questions using pigeonhole principles. Okay, and at that time you will get to know that when you will see those problems of in graph theory, I will discuss those problems. When you will see those problems, you won't even think about applying this pigeonhole principle, because those problems actually won't have anything, anything pigeon or pigeonhole, these kind of things. So but once I solve those questions, then you will be able to appreciate the this pigeonhole principle more. Okay, so right now you will feel that okay, pigeonhole principle is a easy thing, but this is not such a easy thing, because this pigeonhole principle can solve many complex problems. Okay, but let's see. So let's try to solve this question. So this is the question. Among any group of 367 people, okay, so if there is a group of 367 people, there must be at so what it is saying basically, if I have 367 people, then at least 2 of them must have same birth date. Why? Because you know that in a year how many days are there? You know that, let's assume at maximum, for example, when this is a leap year, then there are 366 days. So but we how many people we have? 367 people we have. Okay, so you know that at least 2 person must have same birth date. right? So this is such a simple application of a pigeonhole principle. What is happening here? These dates are pigeonholes. These dates are pigeonholes. Ph means pigeonholes, and these people are pigeons. These people are pigeons. So now we have, pigeonholes are 366 and pigeons are 367, and so of course two, at least two people must go to same pigeonhole. At least two people must go to same date. So basically at least two people must have same birthday, some same birthday. Okay, now let's take next example. Let's take this example. For example, for example, if we have 27 English words, okay, in any group of 27 English words, there must be at least two that begin with the same letter. So basically what it is saying that we have 27 English words. Okay, so there is a word here, then there is a word here, then there is a word here, and so on. Now we are saying that at least two words must start with the same letter. Why? Because you can see, we are only interested in the first letter. We are only interested in the first letter. You know that there are only 26 letters. You know that there are only 26 letters, but we have 27 words. So at least two words must have same starting letter. So basically here what is happening, these 27 words are pigeons, and these 26 alphabetical symbol, these are pigeonholes. Okay, so since we have more pigeons than pigeonhole, hence at least two pigeons must go to same pigeonhole. So at least two word must have same starting alphabet. Okay, so this is such a easy principle. Actually we are only taking easy examples here. Okay, in gate exam they have not asked any complex problem from pigeonhole principle. That is why right now while we are studying combinatorics, we will not take any complex problem here. But I just want to give you some flavor of how we can solve many complex problems using pigeonhole principle. And for that what I will do, when we will study graph theory, at that time I will solve two or three problems using pigeonhole principle. Okay, right now we will not go into the complex problems, because from my experience and also from the previous gate questions, this pigeonhole principle, only the simple questions have been asked. Okay, now try to solve this question. Try to solve this question. Try to solve this question, and I'm just coming. Give me 1 minute. Try to solve it. Okay, so how many students must be in a class to guarantee that at least two students receive the same score on the final exam if the exam is graded on a scale from 0 to 100? So you are answering 101. So actually 101 is not correct. Why? You see what he's saying. The question is saying that how what is the range of marks. So basically either someone can get 0 mark or 1 mark and so on, someone can get 100. So you see, this is the range, and this is saying that how many students must be in a class to guarantee that at least two students will receive same mark. So let's assume you are saying 101 students, you are saying 101 students, let's assume. So what will happen? There is no guarantee with 101 student. Okay, there is no guarantee that at least two will have same marks. Why? You can see that maybe one student can have 0, another student can have this mark 1, and maybe the 101th student may have mark 100. So you can see there is no guarantee here. But if you give me, if you have 102 students in the class, if you have 102 students in the class, then we are guaranteed to have at least two students who will score same marks. Why? Because these marks are actually pigeonholes. These marks are actually pigeonholes. So we have 101 pigeonholes. You see, from 0 to from 0 to 100 there are 101 pigeonholes. Okay, so if we want to guarantee that at least one pigeonhole will contain more than one pigeon, then we should have more pigeons. So basically, if pigeonhole are 101, then our pigeons must be at least 102. Okay, at least 102. So the answer will be actually 102. Did you get it? Oh yes, right. So maybe the mistake that you might have done is that you thought that pigeonholes are 100, because you thought that from 0 to 100 there are 100 numbers. That is, you might have thought. Okay, let me just tell you. One friend of mine actually, in the last year, in 2020, this gate exam, there is a question in digital logic. There is a question in digital logic. There is a decoder, and then decoder has. So basically, if you ever whenever you will solve these digital logic questions, then in 2020 there is a question in which there is a decoder, and that decoder has these many lines. For example, the first line is indicated by 0, and the last line is indicated by 511. Okay, so you can see the question was very simple. Basically, how many lines are there? Okay, the question was very simple, but he answered 511. He answered 511, and he lost. First he lost the marks in this question. Also, he got negative marks. So you can see this is such a simple thing. So basically, from 0 to 511, actually there are 512 numbers, not 511. From 1 to 511 there are 511 numbers. Okay, so these are very small things, but actually this reminded me when you wrote this 101, then it reminded me of him, because he lost marks in such a simple mistake. So for example, let's assume that this question comes in gate exam, and let's assume that you answer it 101. Then when you will come home, and when you will discuss it with your friends, at that time you will be like, oh shit, such a silly mistake you did. So just take care. Okay, nothing to worry, nothing to worry. Just take care. From next time onwards, you don't make this mistake. So this is the solution. You can easily. So there are possible scores, so we need at least 102 students. Okay, so this is the answer. Now let's go to the next question. So now the next topic is permutation combination. So you see this pigeonhole principle is a very easy thing. And today what you can do, so you have mathematical logic to solve. Obviously, if you have not solved mathematical logic completely, then I encourage you to solve all the questions in that Go PDF from mathematical logic. Also, what you can do, you can try to solve questions from pigeonhole principle. Also, you can try to solve. Okay, so you will see that easy questions that only easy question are asked in GATE exam from pigeonhole principle. Now we will move on to the next topic, that is permutations and combinations. So before I start permutation combination, I just want to go through some things, some basic things that you might already know. For example, we have something called n factorial. Okay, right now we are only seeing, okay, what is the meaning of n factorial. So you already might know that n factorial means n into n minus 1 into n minus 2 into n minus 3 and so on. So this is n minus 2, this is n minus 2. So n multiplied by n1 n minus 1 multiplied by n minus 2 and so on, 3 multiplied by 2 multiplied by 1. So this is n factorial. So you might already know. For example, what is 3 factorial? What is 3 factorial? This means 3 multiplied by 2, wait, this is 3 multiplied by 2 multiplied by 1. So this is nothing but 6. For example, what is 5 factorial? What is 5 factorial? That will be 5 multiplied by 4 multiplied by 3 multiplied by 2 multiplied by 1, and that is equal to 120. So this is the definition of n factorial. Okay, now you might already know that this is n factorial. Now, are you familiar with NCR? Can you write yes or no? Are you familiar with NCR or NPR? Do you know the formula for NCR or NPR? Do you know the formula? Okay, so you know the formula. So okay, let me just quickly write for the sake of completeness. So what is this NCR? I'm just writing these formulas right now. We will see how we will use these concepts. Okay, so what is this NCR? This NCR is simple: n factorial divided by r factorial n minus r factorial n minus r factorial. Okay, so we already know what is n factorial. Okay, so r factorial, n minus r factorial, these things you can, for example, if we have 4c2, what it will be? It will be 4 factorial divided by r factorial. R factorial means 2 factorial multiplied by n minus r factorial. N minus r factorial, that is again 2 factorial. Now what is 4 factorial? You can solve it. 4 factorial is 4 into 3 into 2 into 1, that is 4 factorial, multiplied what is 2 factorial? 2 factorial is 2 into 1, and what is 2 factorial? That is 2 into 1. So now you can just, okay, 2 into 2 4, you can just cross it, and it will be 6. So you can see 4c2 is nothing but a 6. Okay, uh, right. So this is the formula NCR. Now what is the formula for NPR? So the formula for NPR is simple. Just okay, remove this r factorial. So you will get n factorial divided by n minus r factorial. This is the formula for NPR. So wait, yes, so this is the formula for NPR. Let me just write here. So what will be, for example, if I say 4p2, what will be this? What will be this? So this will be 4 factorial divided by n minus r factorial, that is 2 factorial, and this 4 factorial is 24, this 2 factorial is 2, and so answer will be this 12. Okay, so this is a very these are simple concepts you might already be familiar, but for the sake of completeness I wanted to discuss these things. So what is n factorial, what is NCR, what is NPR, and you can easily find the relation between NCR and NPR. Why? Because we have already seen that NCR is nothing but n factorial divided by r factorial multiplied by n minus r factorial, and we already know that this thing, this n factorial divided by n minus r factorial, this is nothing but NPR. So we can also write NCR equal to NPR divided by r factorial. This is r factorial. So you can also write like NPR is equal to r factorial multiplied by NCR. So NPR is equal to r factorial multiplied by NCR. So NCR. Okay, so this is the relation. This is the relation between NCR and NPR, and this is what we mean by factorial, and these all kind of things. So you already know. Now let me come to the permutation and combination part. So just one time try it. One time this we have not studied the concept, but still I want you to try this question, because why I am asking you to try this question is that actually these permutation and combination, they internally they use these product rules and sum rule only. So if you know the sum rule or product rule, then you can you know you can answer this question easily. So we have already seen product rule, we have already seen sum rule. So kindly try to solve this question. Okay, Sanjeev is saying 60. So there are two questions here, right? 60 is for first question, 60 and 120. Okay. Gayatri, are you trying, or shall I explain? Explain. Okay. So let's see. So this question, what it is saying, in how many ways can we select three students from a group of five students to stand in line for a picture? So what he is saying basically, there are five students. There are five students, and we just want three students to stand in a line. For example, maybe this is the line. Okay, this is the first position. Maybe this is the front, and this is the last position. So this is a line. Let's assume that this is the line. Now, so we have basically this question is saying maybe a morning prayer in schools. You know the morning prayer. So let's assume there are five students, and this question is saying, in how many ways can we select three students from a group of five students to stand in a line for a picture? In how many ways we can arrange all five of these students in a line for a picture? So basically, okay, in the first question, okay, let's just slightly change this question. Let's slightly just change this question. Let's modify this question, and let's ask, how many ways are there to make three students stand in a line? So basically, just slightly, just I'm modifying this question. We are going to ask, in how many ways can we arrange three students? Can we arrange three students from a group of five students to stand in a line for a picture. Okay, so basically there are 5 students, we have 3 positions in our line. So how many ways are there? So now you can apply the product rule simply, because for the first position you can pick any of these 5 students. For this first position you can pick any of these 5 students, but once you pick one student here, now for this second place you can pick any of the 4 students, right? uh, just I am simply using product rule. Similarly, for this third position you can pick any of the 3 students. So you can see my final answer will be this and this and this, and this will be just 60. So this is just a simple this what you can say for product rule question. And the second question: in how many ways can we arrange all 5 of these students in line? So basically now in the second part it is just saying that all the 5 students are arranged in line. So how many ways are there? Now again, similarly, same way we can solve it. Like for the first position we have 5 ways. We can pick any of these 5 students and we can we can put him here. Now once we put a student here, then we have 4 ways to put another student in this second position. Okay, similarly we have 3 choice here, then we have 2 choice here, and then once we have put 4 students in these 4 positions, we are left with only one choice for this last position. Now our final answer will be just multiply all of them. So this will be 120. So just a simple product rule. But now you must be thinking like, if this is such a simple product rule, then why this question is under this permutation and combination? So the reason is this: what do we mean by permutation? What do we mean by permutation? For example, if we have 3 student A, B, C, and if I arrange them in this order, for example A, B, C, okay, first A, then B, then C. Now if I arrange them in this order, for example B, A, C, now let's assume that this arrangement means that this A is the topper and this B is the second ranker and C is the third ranker. Now you can see that this arrangement and this arrangement are different. Why? Because in this arrangement B is the topper and A is the second ranker. So you can see, for example, if I give you another arrangement, for example CAB, now this arrangement is different from these 2 orders because now C is the topper. So you can see, remember, all these are permutations, because in permutation order matters. In permutation order matters. So basically A B C, C A B, B A C, these are different permutations. Okay, these are different orders. So you can think permutation, okay, you can think like order. Okay, so different orders. So how many permutations are possible? Now if I ask you how many permutations are possible, then you can easily answer it. How? Just use our product principle. How? Because we have these 3 students, we have A, B, C. Now I am asking how many permutations or how many orders are possible. Then we can just simply solve it like this. You know that for the first position you have 3 ways. For the first position you have 3 ways. Okay, this. Okay, now for the second position, once you put one person here, then you have 2 ways. And once you put 2 people here, then you have 1 way. So you can see there are 6 orders or 6 permutations possible. So again, this permutation is nothing but ordering. So basically order matters. So ABC is different from BAC and BAC is different from CAB. Okay, so you can see total with 3 students or with three symbols, we have 6 permutations possible. Now let's assume that we are so this is the meaning of permutation. Okay, now we will see what is the meaning of combination, but before that let's solve some questions on permutation. So this is the solution. You can just easily solve it. Okay, actually why I had to change this question slightly, because actually instead of this word select, there should be arrange here. Okay, we will see what would happen if there was this word select here. Okay, we will also see that. But actually it will not make much difference. just to just to not confuse you, I changed this word select to arrange. Okay, but even if this word we keep as it is, even if if we keep it as it is, we do not change it and we solve this question, then also answer will be same. But I do not want to confuse you, that's why I just changed this language of this question. Okay, we will revisit this question when we will study combinations. At that time we will revisit this question, and at that time we will solve this question as it is, without without modifying its language. So don't worry. Now, so this is the solution for that question, you can refer to it. Now, I think time, okay, we have some 6 minutes we have. But select is NCR, right? So that's, yeah, that's what that's why I changed the question, Sanjeev. That's why actually I modified this question. I replaced the word select to arrange. So the reason is, we will revisit this question after we study these combinations. At that time we will see what is the difference. Okay, right now you do not need to worry about it. Just consider the modified question. I modified the question, right? I changed the language of the question and then we solved it. So right now you just consider that. And once we are done with permutation and when we go to combinations, at that time we will see this question again. Okay, so the permutation is basically this. This is the definition of permutation. If we have n objects, then the permutation is nothing but the ordered arrangement. So basically order matters. Okay, so a b c, this is different from b a c, this is different from c a b. So you can see order matters. Okay, so permutation is nothing but a ordered arrangement. Now, for example, what will happen if we have n elements? Then we will if we have n elements, and if we want to arrange them, if we want to find the number of permutations of these n elements, then we can simply, okay, find like this. There is a very easy way. You already know, by product principle you can find it. Why? Because you know that permutation is nothing but a ordered arrangement. The permutation is nothing but a ordered arrangement. And since we have n elements, hence for the first position we can pick any of these n elements. Okay, now once we pick one element here, now for the second position we cannot pick obviously this element. So for the second position we have n minus 1 ways, for the third position we have n minus 2 ways, and so on. So finally, by product rule you can just multiply them. So it will be n multiplied by n minus 1 multiplied by n minus 2, and so on. So you know what is this value? This value is nothing but n factorial. So basically what I want to say, if you have n elements, then the number of permutations for those n elements will be n factorial. Okay, assuming that all these n elements are distinct, assuming. Okay, so let's assume these are n different students. Okay, we will also see what will happen if some are if all are not distinct, some are same. Okay, so we will also consider those cases, but we will go one by one. So this is the answer for if what will happen if we have n distinct elements and we want to find number of permutations. Then the number of permutations will be n factorial, and we can simply use our product principle. Because using product principle, what we can do, for the first position we have n ways, and once we put something in the first position, then for the second position we can pick any of the remaining n minus 1 ways. Then for the third position we can pick any of the remaining n minus 2 elements. Okay, so this is the way. Now the second thing is what will happen. Now the second thing is what will happen if we have n elements. Let's assume we have n elements, but we want to pick r of these elements. What we want to do, basically we only want to pick r of these elements, and then we want to arrange them. Just like in the previous example, if you remember that example, we had 5 students. Even though we have 5 students, but we only want 3 students to stand in a line. So this is the same question here. So if we have n students, and assume that we only want r students for example, let's assume the length of this line is r. Okay, so we want r students to stand in this line. So how many ways we can do this? So you know that for this first position we can pick any of these n elements. For this second position we can pick any of the remaining n minus 1 elements. Okay, so for example, just like in this question the first we had 5 ways, then 4 ways, then 3 ways. Okay, so if we solve this question for uh, if we solve this question for let's assume there are n elements, and we we have a line, we length of line is r only. So you know what will be the answer will be n multiplied by, for this second position we have how many ways we have, n minus 1. Okay, so we can pick any of these n elements, and we can put it here. Then once we put a student here, then we can pick any of the remaining students, okay, n minus 1 student, and we can put it here, and so on. Now you know that since there are only r boxes, so this will be n minus r plus 1, because there are only r boxes. Okay, so since there are only r boxes, so in the first box we put n, or I can write it like n minus 0, n minus 0. In the second box I put n minus 1. In the third box I put n minus 2. So similarly in the rth box I will put n minus r plus 1. I hope you understood how this is coming, right? Because in the first box we are putting n minus 0, in the second box we are putting n minus 1, in the third box we are putting n minus 2. So in the rth box we will put n minus r plus 1. So n minus r plus 1. So this will be the number of permutations possible. Number of permutations possible. So these are called r permutations. So basically, why we are calling it r permutation? Because even though we have n elements, we are only interested in the arrangement of r elements. So that's why it is called r permutation. So now we have already covered what will be the what will be the formula for r permutation. So if we have n distinct elements, and if we want to make r permutations, if we want to make r permutations, then what will be the formula? The formula is simple: n into n minus 1 into n minus 2, and so on, n minus r plus 1. And if you notice this, actually this is same as npr. This is same as npr. You can solve npr because npr is nothing but n factorial divided by n minus r factorial. And if you expand this n factorial, then this n factorial can be expanded like n into n minus 1 into n minus 2, and so on. Finally we will somewhere we will come across this n minus n r factorial. At that time we will just we will just cut it. So finally we will be remaining with this n into n minus 1 into n minus 2, and so on, n minus r plus 1. So this is the formula for npr. So this again, we can also write like this: if we have n distinct elements, then the number of r permutations will be npr. And what I have already mentioned, what do I mean by r permutation? So r permutation means even though we have n distinct elements, but I only want to arrange r elements. Okay, so that's why this formula will come. So if we have n distinct elements, then the number of r permutations will be npr. Okay, now what will happen if we want to arrange all the n elements? Then what will happen? Then this r will be equal to n. This r will be equal to n. So what will happen? This r will become equal to n, and our answer will be npn. And this npn is same as n factorial. Why this npn is same as n factorial? Because npn is nothing but n factorial divided by n minus r factorial. So this is 0 factorial. And just to remind you that 0 factorial is actually 1. Remember this: 0 factorial is taken to be 1. Okay, so 0 factorial means 1. Also, if I am talking about these things, then I let me also tell you that 0 factorial is 1. And if I have any negative number, if I have any negative number, for example minus 1 factorial, then that will be 0. Okay, so just remember these things. These are conventions basically. 0 factorial is 1, and any negative numbers factorial will be 0. Any negative number. Okay, so these things. Now you can solve this question very easily. If we have set basically we have 3 distinct elements. Now if you want to find number of 2 permutations, then the formula you already know: npr 3p2. So what will be 3p2? 3 factorial divided by 1 factorial, and that will be 6. sorry, and what is NPR? NPR is basically 3 factorial divided by 1 factorial. So yes, so the answer will be 6. So two permutation, number of two permutations will be this 6. Also you can solve it by our product method. How? Because you only want to arrange two elements, so the first element can you can pick any of these three elements and you can put it here, and remaining two elements you can put it here. Sorry, one element from the remaining two elements you can put it here. So finally our answer will be 3 into 6. So okay, let's just okay end today's lecture. Just to remind you, this permutation and this combination, these things actually internally use product rule and all the basic rules that we have seen. You can see everything that we have done so far actually, that uses either product rule or sum rule or division rule or subtraction rule, these kind of things. So those rules are the basic rules. So whatever we study actually from now on, that actually internally uses these product rules, sum rule, and these kind of basic rules. Okay, so we have seen what is a permutation. Now in the next class we will take examples on permutations, and also we will study combinations. So after permutation and combination we will take some complex problems which require the knowledge of permutation combination both. Okay, so involving both basically. We will also use permutation also, we will also use concepts of combination also. So far we have only seen the concepts of permutation, we have not seen combination. So after that we will take binomial theorem, and then after that we will take some complex problems. Okay, and with that our this chapter combinatories will be over. Okay, the thing is this combinatories is actually a tool, and in all the remaining chapters, for example group theory, graph theory, set theory, in all those remaining chapters we will have questions which will use this combinatories concepts. Okay, so even though, okay, you are saying that, sir, how is minus 1 factorial 0? Actually don't worry about this is just for convention. Okay, this is just for convention. Like uh, actually like 0 factorial is taken to be 1. 0 factorial is taken to be 1. Okay, so they have decided this convention, like even though this n factorial, this n should be a sorry, this n should be a positive integer. This n should be a positive integer. So basically this factorial is defined for positive integer only. But sometimes in more advanced applications, in more complex problems, sometimes these 0 factorial and minus 1 factorial, these kind of things also come. So they have just they have just assumed 0 factorial to be 1, and they have assumed any negative numbers factorial to be this you can say 0. Okay, but if you want to find the intuition behind this 0 factorial being 1 and this negative numbers factorial being 0, if you want to find the intuition behind this, then tomorrow after we study this combination chapter, okay, this combination topic, at that time I will tell you why these negative numbers factorial is considered to be 0. I will tell you the intuition behind these things. Okay, so till tomorrow you just by heart it, and tomorrow I will give you the I will tell you the intuition behind this thing. Okay, okay, so this is enough for today. Let's end today's lecture. Let me if you have any doubts, Sanjeev, Gayatri, kindly ask me. Okay, so Sanjeev, we will consider this. I will answer this question of yours. Okay, tomorrow I will answer it after studying these combinations. Okay, at that time I will tell you what is why they did this. Okay, why these mathematicians actually assumed negative numbers factorial to be 0. So there must be some intuition. There must be some usefulness. So we will see this in tomorrow's lecture, in the next lecture. Okay, thank you everyone. Let me pause the recording. Yes, now it's fine. Yes. So this combinatorics is a field of mathematics in which we count things. So mostly we will be counting things. This is the actually structure. So these are the things that we are going to study. First we will see the basic principles. So we will see the very basic principles of counting, the product rule, sum rule, these kind of things. Okay, and also principle of inclusion exclusion. So the first thing we will do is we will see these kind of basic things. Then we will see one more principle, that is pigeonhole principle. Then we will talk about permutation combinations. Then we will talk about binomial theorem and binomial coefficients. So then we will go in more like these are the, in these cases we will solve easy questions. Now in this topic, this generalization, okay, here we will take more like complex questions. At the end we will talk about like generating functions and and then we will take more examples. So this is the structure of what we are going to study in this combinatorics chapter. Let's start. But the thing is, this combinatorics is actually comparatively easier, because you can see like the mathematical logic, the propositional logic, first order logic, these kind of things we study in computer science. These kind of things we have not studied in till our in our school or in general mathematics. So that's why mathematical logic was a different topic. Okay, that had some new terminology, some new notations, these kind of things were there. Okay, but this combinatorics, this counting, this we have been studying since our school. Even in our school we have seen these kind of things like permutation, combination, so these kind of things. So this is comparatively easier topic. Now let's start. So first, remember that this combinatorics is actually a typical mathematics. What is a typical mathematics? A typical mathematics in which you study some tools, in which you study some tools you study, and then using those tools you solve problems. Okay, so if I give you some problem, then what you will do? If I give you some problem P1, then what you will do? You know that you know many concepts, and then you will just go through this problem, and then you will decide which concept or which formula or which tool to apply to solve this problem. So this is what we are going to do in combinatorics also. In combinatorics also we have some set of tools, some set of formulas, some set of laws, some set of theorems. So we will study all those theorems and all those things. Then when we encounter a question, then we have to like decide uh, with our problem solving capacity. We will decide, okay, which tool to apply, which formula to apply, which theorem to apply. Okay, so the first the first rule that we are going to see is the product rule. This is a very basic rule. Let's see what is this product rule. So this product rule says that let me take an example. The example is that let's assume that you want to make two-digit number. Let's assume that you want to make two-digit number. So like for example 0001, okay, like 99. So all these are two. What happened? Automatically zoomed. Yes, so what I'm saying, so let's assume that you want to wait, some problem is there, just give me 2 minutes. Wait. Hello. Recording we have already started, Sanjeev. We have already started recording. Okay. So let's see. So what is this product rule? So let's assume that you want to make two digit digit number. For example, this 00 is a two digit number, for example 99 or 91 or 19, these kind of numbers. So if you want to make two digit number, then how many two digit number you can make? So that is our question. How many numbers are there? For example 0099, so if you count like 1 2 3 4, then how many numbers are there? So to solve this, we can see one thing, that if I want to make two digits, then what I can do, I can make this first digit in 10 ways. Why? Because I can put anything from 0 to 9 here. I can put anything from 0 to 9 here. So I can make this first digit in 10 ways. I can make this first digit in 10 ways. So basically, actually our task is to make two digits. But now what we are doing, we are we are dividing this task in two tasks. The first task is let's make first digit. The second task is let's make second digit. So the first task is how many ways are there to make this first digit. So you know that there are 10 ways. Okay, you can put anything from 0 to 9 here. So this will complete our first task, and that task is to make first digit. Now our second task, so the first task was T1 and the second task was T2, and our main task was T. So this was our main task, that we want to make two digit number. So we have completed task T1. So basically when I say we have completed task T1, that means that we have put one of these digits here. So let's assume that I put 9. Let's assume that I put 9. So you can see that task T1 can be done in 10 ways. Task T1 can be done in 10 ways. How many ways are there to